Hello and welcome to the Daily Space for today, December 30th, 2019. Today, our news is far less exciting than I might have hoped. Specifically, we've all been hoping that Betelgeuse will explode. But Betelgeuse doesn't care what we want or what we hope. It's going to do as it pleases. Now, for those of you who haven't caught the news yet, the upper left corner of the constellation Orion, the star Betelgeuse, this amazing super red giant star or red supergiant star, has been suddenly dimming in ways that have previously never been seen. And we don't really know what's going on, and with this lack of knowledge comes the ability to wildly speculate. And we've been speculating maybe. We hope it will explode, but probably not. So here's what we know. Betelgeuse is a supergiant star, over 10 solar masses in all likelihood. It's kind of hard to measure the mass of this star. It's located 650 light years away. Thank you so much for the bits. Hi. I will give you treats in a moment. It's located about 650 light years away and will probably live no more than 10 million years and is currently probably over 9 million years in age. Thank you so much for this sub. Now, given this star's particular size and age, it's going to go supernova. And it is one of the stars most likely to go supernova in our sky. Hello, dog. I have an invader. I am so sorry. So with Betelgeuse planning to go supernova at any time, anytime it acts weird, we get hopeful. Now, the thing is, it takes hubris to say a star is going to go supernova when we don't really have the data to back it up. And a good observer says, in all likelihood, the most boring outcome is the one that's actually going to happen. So here's what we know. As I said, it's over 10 solar masses. It's going to go supernova someday. It's over 9 million It's over 9 million years old. And what we don't know, though, is what do stars do right before they go supernova? We don't know how long they act weird. If they act weird, thank you for the bits. If they do act weird, how do they act weird? Is the way Betelgeuse is behaving characteristic of a star about to go supernova, or is this just a variable star varying in a new way? Betelgeuse is what's called a semi-regular pulsating star. Its outer atmosphere is in the process of being exhaled with massive stellar winds, and there's a nebula building up around Betelgeuse, driven by, this mass loss, and it can be seen in infrared images. It has been slowly varying in brightness for centuries. It doesn't do this in a way we can predict necessarily, although in recent decades and centuries, we've seen stops. We've seen in the past recent decades a period of about 400 days. And while its brightness changes are anything but consistent, the one thing we do know is, at least in modern history, it hasn't gotten as faint as it is right now. So we want it to go boom, please. But in all likelihood, this is just a particularly low in its normal behavior, in all likelihood. And the next month is going to be super interesting because astronomer Ed Guinan at Villanova University has been following this star in detail and has documented it as having a roughly 400-day period, and it should begin to increase in brightness in January. And this is something you can see. If you go outside and you look at the constellation night after night, and you look at all the surrounding stars, you can train your eye to go, okay, so Betelgeuse appears a little bit fainter tonight. It appears a little bit brighter tonight. And you can track it for yourself and figure out, is this star going back to behaving like normal, which would be boring, but is most likely, or is it continuing to be weird? And that was really the most awesome option, is the continuing to be weird. But again, space doesn't care what we want, what we hope for. And Betelgeuse is going to do whatever science that we don't yet know and understand dictates it should do. So here's to hoping for a supernova. Here's to predicting nothing will happen. But here's to wanting something really weird to happen. Okay, on to our next story. In general, this is a pretty slow news time. This is because, well, right now it is the holidays. It's the end of grading horribleness for faculty members who are researchers. And it's prep time for the American Astronomical Society meeting. This year, the meeting is going to be next week in Honolulu, Hawaii, and I'm going to be there along with my colleague, Fraser Kane. And we're going to be working to bring you as much content as we possibly can. That said, Hawaii is in a really horrible time zone for this particular show. So I don't know if we're going to be able to bring you live content at our normal time. If we can't, I am going to be working on, well, we're a crew. Someone will be here bringing you the news. It just may not be me, but I will likely be coming on at other times, bringing you daily summaries of the cool stuff that is coming out at the American Astronomical Society meeting. Now, slow news week isn't the same thing as a no news week. And we did have two statistically interesting, statistics-based stories to bring you this week. The first of these two stories is one that looks at the three-body problem. Now, hopefully you've heard of either the book or the physics problem or both. But for those of you who haven't, first of all, go read the book. It's pretty cool. Second of all, the book has nothing to do with the physics issue. And the physics issue behind the three-body problem states that while you can predict some situations where there's three different objects gravitationally interacting, if all three of those objects are roughly the same mass, chaos is going to ensue. So if you have two large objects, you can have a third smaller object that is either orbiting both of those large objects if they're close in together, or is orbiting one of those two objects if they're widely spaced. If you have one large object and two small objects, they can orbit in all manner of different ways, as we see with planets, moons, here in our own solar system. But if all three objects are roughly the same mass, you end up with all sorts of weird resonances. You end up with them deforming their orbits. It's essentially a battle for dominance, as each wants to be the center of mass of the system, and none of them actually are. And in these systems, it appears that consistently one of these three bodies is going to get ejected, and the other two are going to end up snuggling together to form some sort of a tight orbit. How that happens, when that happens, who is ejected, it's almost impossible to predict. Thank you so much. Now, in the statistical study, which has been published in the journal Nature, it is shown that in all likelihood, systems follow statistical, probabilities. So that if you look at what are all the different ways that these three-body systems can come together, you can see that the most likely outcomes fall in this, and the most unlikely are over here doing that. And this and that are very vague, but essentially there's a whole lot of incoming parameters. but what is likely to be the result can be predicted statistically. And this has a lot of applications. And one of those applications is looking at globular clusters, where systems of 3 stars regularly get thrown together in the tight, crowded cores of these clusters. And the result can be, well, black hole systems that eventually merge together while a third body gets ejected out. And by understanding what is the likely set of orbits that are to result of those systems that end up getting thrown together, we can start to predict what types of gravitational waves are likely to be seen when those black hole systems eventually merge. It allows us to start to look at what's going on down in the centers of merging galaxies, where we have 3 supermassive black holes battling for dominance in the center of these new systems. And who is going to get ejected? So there's a lot of different applications, but this work is in its early days. It's just cool to see that through simulations, through application of chaos theory, and through a whole lot of statistics, we're starting to be able to conquer areas of science that don't have any straightforward solutions. Now, a second statistical study came out also looking at, well, how do we use models to figure out what is the likelihood of different things happening? But in this case, it's nothing as hard to understand as a 3-body problem. Instead, what this team was looking at in a paper published in the monthly notices of the Royal Astronomical Society is, what is the likelihood that those comets we see out there, long period comets in particular, are ones that formed in our solar system versus formed in another solar system. This team ran over 4 million simulations looking at what happens when you throw, thank you so much, Keeper, for the tip. This set of simulations took a look at, well, what happens when balls of ice and rock encounter our solar system with a velocity distribution resembling what we observationally see from the stars around us. What of those comets get captured by the gravity of the Sun and Jupiter? And what continue to fly away? And what they found is anywhere from roughly 100 to roughly 10,000 comets at any given time that you might find in our solar system actually originated somewhere entirely different. And their orbits can resemble the long period comets that we regularly see as originating from the outer parts of our own solar system. This means some of those long period comets that we've observed over the centuries are probably actually alien in origin. Yes, folks, there are aliens among us. They just aren't biological in nature, but rather they're some of the comets and asteroids that we see out there. And we'll never know which ones they are. At least we don't have a way of figuring it out right now. And this is just kind of cool. Turns out, well, when we consider the origins of everything we see in our solar system, we have to consider, what did we gravitationally steal from some of our stellar siblings? And that's it. That's all the stories I've got for today. But I will stick around and answer your questions. While you're typing those in, I'm going to go ahead and remind you to please use the purple circle with the purple star in the center, and that will help me find your questions in the chat. While you're typing them in, I'm going to let you know that this is a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. This show is produced by Susie Murph, and we are currently working on raising funds so that we can stop asking you for funding quite so much in 2020. The difference between what we normally bring in each month on bits and subs and what we need to be able to pay all the folks that you see at CosmoQuest who keep our software going, our servers running, that create all the, ways that you can get involved in science. The difference between what we make and what we need is that $40,000 we're trying to raise. And we're hoping that with your help, we don't need to keep saying, hey, this month we need to make this much money to pay our bills. So if you want to see me being able to pay Susie and Annie so that, well, Annie can eat and Susie can make sure her kids go to college okay, well, consider giving. All right, that's it. I'm going to try and figure out how to, first of all, make the chat a little bit bigger. I think I have a keyboard I can use to do that. Yes, I do. All right. So I'm going to go ahead, and I see folks asking me to give the dogs treats. I have both Malachi and Eddie down here with me right now. Thank you so much for the bits. Hi, you can come up now, Eddie. Come here. No, Eddie, come back where you were. Good boy. Up. Okay, come here, Malachi. Okay, so all of the dogs get treats. For those of you who don't know what's currently going on, your bits get turned into Cheerios, which get turned into cuteness via the munching of dogs. All right. I didn't quite get my monitors lined up this morning when I set up, so you get to deal with me looming as I try and read through the chat. So I'm scrolling up to the very top to see what all I might have missed. Scrolling. You guys had a busy chat today. All right. Thank you, Wayne Johnson. Hello, Wayne Johnson. Hello, Paranor. Hello, Nightbot. It's making more noises. I don't know why all it's making noises. I will scroll and find out. Yeah, Bad Panda. No boom today. Very sadly, no boom today. Checker Kev points out, lead story of the day every day until Betelgeuse has not blown up. That might be a while. Keeper writes, I'm hoping it is waiting for there to be clear skies where I am. I have to admit, I haven't been able to see Betelgeuse be faint yet, and it's kind of driving me crazy. It's like really gross outside here in Southern Illinois. But I've been following along, and the Bad Astronomer Phil Plate was able to post a photo he took last night. And yeah, it looks super weird right now. Thank you so much for the sub, Paranor. Susie Murph is like, boom tomorrow. There's always a boom tomorrow. Thank you for the bits for science, Paranor. Eddie is ready for his close-up. Ironheart, thank you for the sub for 5 months. That's amazing. Yes, Eddie did totally get on camera. Hello, Larry. Hello, Keeper. Thank you again for the bits. Hello, DPI209. Hi, I see you, nose-poking dog. Hello, Space Dive. Thank you for the bits. Hello, Southern Cross. Planetary Pan asks, are there any other stars more likely or as likely to go supernova that we should be paying attention to? Eta Carina. So in the southern hemisphere, the star Eta Carina is another supergiant. In this case, it's very blue. It's in a binary system. It had a false nova event in the 1800s where it went from being one of the fainter stars in the Carina constellation to being the brightest. This is why it's named Eta Carina, where Eta isn't the first letter in the Greek alphabet. Seems really weird. It was named when it was fainter than it is now. Eta Carina could go boom. It's the other one that we should watch. And there's a few others out there, but generally Eta Carina and Betelgeuse are the most interesting to think about going boom because they are already such bright and not very distant objects. Betelgeuse, for instance, is 650 light years away. And the Crab Nebula, which was a bright supernova in 1054, its supernova remnant is visible with binoculars, but not with your unaided eye. Betelgeuse, its nebula will be visible to the unaided eye, and that's just kind of something I would love to see. Hello, Southern Cross. The saucepan is here. That is, in fact, the shape you look for when looking for the Southern Cross. Bad Panda asks, does the dimming of Betelgeuse correspond to it shrinking or getting larger? It corresponds to it shrinking. So in general, with pulsating variable stars, the overall luminosity is due to the surface area of the star. So as they shrink, you have less surface area to be shining light. We also normally see temperature changes with this pulsation. And the one piece of data that I really just need to write Ed Guinan and ask about is, are the temperature changes that we'd expect currently going on? I just don't know. And a lot of the data we have on the brightness of Betelgeuse actually just comes from people going outside with well-trained eyeballs and going, Betelgeuse is this brightness compared to the things around it. And our eyeballs, while fairly accurate at measuring brightness, aren't fairly accurate at measuring color. So I don't know how its color has currently changed. Okay, let's see what other questions we have. No boom today. Yep. Yeah, Nancy's coming. She could tell that it's dimmer and she's not an active astronomy brightness measuring human. Keeper, you're so full of lies when you say that time zones are our friends. Time zones are our enemy. Southern Cross. So Frasier Crane is a fictional character from the psychology show that does indeed have a dog named Eddie. I hadn't thought of that part before. Fraser Kane, not Frasier Crane. Fraser Kane is a Canadian astronomy news producer. He runs Universe Today. And due to the similarities in his name and the fictional character's name, he has essentially never been able to establish a Wikipedia page, because as soon as it goes up, someone tears it down saying, no, this isn't real. This is a fictional character. So check out universetoday.com, The Guide to Space on YouTube. He does really good content. He and I have been producing the Astronomy Cast podcast for 13 years now. So, yeah. And Susie's pointing out she has a camera now. So Susie and Annie next week will be able to produce this daily stream when I'm not around. So Veronica Cure writes, it's so far away. Whatever is going to do has already happened. If we had something closer, sensor or camera, could we know ahead of time? So we're always limited by the speed of light. This means that while Pluto is 5 light hours away, roughly, very, very roughly, in some parts of its orbit, if Pluto were in its orbit such that it was closer to Betelgeuse than us, it might know 5-ish hours ahead of us that Betelgeuse went supernova some 650 years ago. But it couldn't send us that information ahead of time because the messages it would send are traveling at the speed of light, just like the light from Betelgeuse. So we're stuck. We can only know when the light has had time to reach us, and anything that detected it before us could only send signals that are traveling at the same speed that the light itself is traveling at. Yeah. Now, the neutrinos from the supernova will arrive because they're generated sooner before we see the supernova itself. And that's due to the delays in when things happen during the explosion and the fact that neutrinos do travel at close to the speed of light. But in all likelihood, we won't be able to parse out what's happening such that it makes any meaningful difference. Okay. Looking for more questions. I'm enjoying all of the discussion about the three-body problem, both the book and the physics. So Larry writes, is Ice Cube neutrino detector about to detect direction? To what degree? So neutrino detectors can't accurately tell us where on the sky the neutrinos are coming from. This is because they rely on a neutrino entering the giant cavern container, whatever, of scintillating material, liquid that gives off light when it interacts with the material. And that neutrino can enter from any direction. And the photon of light is going to be given off in a random direction during the interaction. Now, if multiple neutrino detectors around the world are able to all detect neutrinos such that there is a noticeable delay between the different things caused by the speed of light, then we can start to say that quadrant of the sky. But if the neutrinos are arriving over a span of time, it may get hard to use this information in a meaningful way. So there's the potential to use multiple detectors, the same way we do with gravitational waves, to look at light speed delays between the different detectors to say, yes, that quadrant of the sky where we happen to be seeing this giant supernova is the origins of the neutrinos. But if the neutrinos are arriving over a long period of time, that will blur out any of the delays we might see. It's just hard. So we're not quite at the point of getting accurate directional information out of neutrinos. Doesn't want to scroll. Come on, chat, scroll. There you go. So thank you, Southern Cross, for the follow. Hello, Rocket Sage. Thank you for the bits. Eddie just hit his head on my desk standing up because he wants bits. Hi. Yes, I will give these to you. I have a dog on either side, but the other one is far less aggressive. About food. I like the sloth head with snowman arms, Veronica Cure. It's kind of hilarious. Thank you so much for the tip. I can't see from here who it is, but when I get there in the chat, I will thank you by name. So Creamy Goodness is asking, if I get beamed up, am I getting moved or cloned, and then murdered? So my understanding of most transporter technologies in fictional books, is that you're getting cloned and murdered. Yeah. Thank you, Keeper of Maps, for the donation. Bad Panda Bear asks, can the statistics for the three-body problem be generalized to n-body problems? Not yet. So in order to get at their statistical understanding of different three-body outcomes, they had to run simulation after simulation after simulation of how three bodies are interacting. And from that, they began to see probabilities crop up of this is more likely than this. To do 4 bodies is going to take more computational power. To do 5 bodies is going to do more computational power. And until you run all the simulations, you can't really see what statistical trends are building up that you can use to predict n bodies. So we're not there yet. Give it time. Give it better computers. DPI209 is like, yo, I heard you like palindromes. I totally do. It's the donation thing right now, a palindrome. I can't see that far, people. I'm so sorry. It's a Monday. My computer is too far away. And for those of you who don't know what palindromes are, it's when something can be read the same way when you reverse it, when it's a mirror image of itself. So, for instance, 32123 is a palindrome because it's the same number in both directions. And I just appreciate symmetry. Creamy goodness, that is a very sad story or pun on the three-body problem. I think the side eye you got may be the correct response because I'm hoping that that was just a trolling joke. Hello, Hexacosacoron. It's never aliens. No, DPI. It's never aliens until it is aliens. At least biological aliens. It could be an alien world that we're discussing, in which case those exist. There are exoplanets out there. It's important to know what it is that the word alien is modifying if you're using it as an adjective. Now, if you're using it as a noun, all manner of chaos are going to ensue. Thank you for the follow, Snizebump. I have no clue how to say that. Scrolling for more questions. So Creamy Goodness says, if I get beamed up, am I getting moved? Oh, I already got that one. Yes, cloned and murdered. Scrolling for more questions. Scrolling. Binary Ablaze is like, feed Annie. So Binary Ablaze is my co-host. She does Rocket Wednesdays and fills in when I'm away. Susie Murph is our producer and also fills in when I'm away. The dogs are Eddie and Malachi, who Malachi is never on camera because he's shy. Thank you, Wayne Johnson, for the 300 bits. Thank you. Scrolling. Binary Blaze is getting ready to take, I think it is her nephew, to the candy store. Oh, we have all sorts of puppy love around here, Broken Symmetry. Thank you for the follow, Extreme 360. Hello, Raj Luthra. Hello, Zazink. Guido says, just wanted to say hi from Berlin again briefly, but I gotta leave again. Don't know there would even be a daily space today. Yeah, I needed to get back into the habit of things this week. We will probably skip New Year's Day, just because even I like to sleep in occasionally. But other than that, we should be going this week as normal. Thank you, Paranor, for the sub. Thank you, Cosmic Drifter, for the sub. It's a fabulous username. Scrolling. I see Revsmat asking thanking Babylon 5. I kind of love Babylon 5. I have so far managed to miss seeing Babylon 5 in the chat, but hopefully I will notice it eventually. Thank you, Revsmat, for the bits. So Hexacosacoron is asking, so is Betelgeuse noticeably different to the naked eye? Yes. In general, it is the brightest red star in the northern hemisphere. Currently, it is fainter than Aldebaran, the burnt orange eye of Taurus the Bull. It is so noticeably different, in part just because of the comparison. It usually is one of the top 10 brightest stars in the sky. Currently, it's outside of the top 20. So when you look around and compare it to other things, it just doesn't shine as bright and pop out the way we're used to. Scrolling. I'm enjoying the debate between Legos and candy. Can't we have both? Gilda Sitar asks, how long will its remnant be visible to the naked eye? So the thing that I look at is brightness goes as the square of the distance. So if something is half the distance away, it's 4 times brighter. If it's 1/3 the distance away, it's 9 times brighter. Well, Betelgeuse is 1/10 the distance of the Crab Nebula. The Crab Nebula is visible with binoculars as an 8th magnitude object. Now, brightnesses are logarithmic. So, all because it doesn't go in a straightforward fashion. It's not a straight factor of 10. It's confusing. I need to sit down and actually work the maths for this one. But since Orion's Betelgeuse is 10 times closer, the remnant, more than 1,000 years after the supernova, should still be visible to the eye in the sky. The Crab Nebula was formed in 1054. We can still see it with binoculars. Orion should be 100 times brighter, and so it should be visible from eye even 1,000 years after the event. Again, I need to work the exact maths. I love all these people who are like, maybe Betelgeuse is waiting till we have better weather. The universe does not care, people. The universe just wants us dead. It tries to kill us on a daily basis. Creamy Goodness puts, time zones are the tool of the devil, and I tend to agree. Nancy is cursing time zones. Yeah. So Revsmat asks, are there metal oxides in Betelgeuse's atmosphere like the zinc oxide or titanium oxide, sunblock? So its atmosphere is cool enough that it can have molecules. I don't know exactly what molecules it has. I like the way you're thinking. Scrolling. So Raj Luthra is asking, do I have any plans for New Year's Day? I'm going to reach out to some of my friends and see if anyone wants to get together and drink beer and play board games. But that's about as complicated as it gets. It also depends on how much work I get done this week. Unfortunately, because the American Astronomical Society is next week, being an astronomer has ruined my ability to celebrate New Year's every year since I was an undergraduate. It's one of the really bothersome things about the fields of astronomy and planetary science is NASA likes to schedule mission encounters on holidays so that more of the public can experience them, which means every science communicator and every member of the relevant science team can't celebrate their holiday. Our big planetary science meeting, there's 2 of them, the American Geophysical Union, which there's actually 3 of them. The American Geophysical Union meeting, which always destroys Thanksgiving because you're madly prepping to get ready for this December meeting. There is the Lunar and Planetary Sciences Conference, which always eats your spring break week, which even as a faculty member, you really look forward to. And then there's the Division of Planetary Sciences meeting, which it's actually completely reasonable and is just a random week in October. But then the American Astronomical Society meeting is always the first full week of January, which means it destroys your New Year's holiday. So all these different conferences are like, hey, we're going to destroy your holiday so that we don't interfere with your ability to teach classes. And it just kind of gets exhausting. My husband has kind of given up on holidays. And yeah, it's what it does. Anyways, things to be bitter about when you're a scientist. Go Canada. Yes, go Canada. Looking for more questions. I'm so behind in the chat. So behind in the chat. Oh, Raj Lutha points out that Fraser and I got this year's Parsec Award for Best Infotainment Podcast from the Parsec Awards. And we're super excited after so many years to finally win. Wayne Johnson highlights. This is the file I used to print out Bennu. Ooh, cool. So you can download the plan for Bennu from Thingiverse. Hello, Bill Nash. The neutrinos are coming from inside the house. Yes, they are. I love that horror story reference. Good morning. Looking for more things, questions. Thank you for the bits, Checker Kev. Again, I need to set up all of my equipment again because I have to awkwardly look around in order to read the chat. Thank you for the tip, Wayne Johnson. Scrolling. Thank you for the follow, Lady Elaine. Bill Nash is excited about the fact that transporter beams would murder and clone you. I love that excitement. Aaron Ravage writes, Crewman Redshirt, please get on the clone and murder platform. Yes. So many philosophical issues. Keeper of Maps tipped us with melting snowman unicorns. Oh, the current bit level was 931139, which is a palindrome. Thank you for sharing that, Paranor, where I can actually read it. I really need to set things up. Thank you, Veronica Cure, for also relaying the information. Yes, it's a taco cat. It's a palindrome like taco cat. So DPI209 asks, if you appreciate symmetry, do you appreciate supersymmetry as well? No, I do not, because supersymmetry and string theory, they just don't have any observational requirements to exist. And so far, the things that they've tried to produce have failed to show up. Until there's observational evidence for either of these things, I'm gonna sit over in the corner being skeptical. Bill Nash is like, we're gonna need another Timmy, referring to the transporter pad issues. So Gildestar asks, how large will the remnant of Betelgeuse get before it can no longer be seen by the naked eye? How long before it can no longer be seen with a telescope? Over 1,000 years. That's all I really know at this point. I'd have to sit down and do the maths, and I just haven't done that yet. Thank you for the follow. Hexacosacoron says, I bet you love the Weird Al song Bob, and I'm having a moment of blanking out because I'm apparently a terrible human being. Does Bennu have microscopic aliens? Not that we know of. It does appear to have organic materials, but they aren't biologic in nature. They're just carbon molecules. I want to scroll to the bottom and see what's going on and then scroll back up. So a bunch of things just made noise. Thank you for the follow, Wally. Thank you for the follow, Amoni Madness. Thank you for the follow, Carl Alon. Bill Nash writes, never trust a man with a transporter pad and a lime pit. For those of you not getting the lime pit reference, it's because lime is a way that you can disintegrate bodies rather effectively. You can also just feed them to pigs. Okay, I'm sure I missed things in the chat. I'm just not sure where. Okay, trying to go back up to where I was. Oh man. So okay, there, I found my Bob reference. So Refsmad asks, the soot does get ionized and blown away, but in some variables it accumulates, like our corona borealis. Yes, there are some variable stars that just periodically dim out completely because they essentially shed carbon for reasons that we're still working to fully understand. And Binary Blaze is like, I don't have to do rockets this week. No, you don't. This is true. You got 2 weeks off because this is the magical year when both Christmas and New Year's are Wednesdays, which for a lot of people means 2 weeks off. So Keeper asks, if Betelgeuse goes pop on New Year's Eve, will there be a daily space on New Year's Day? In that particular instance, yes, but that's like the special case. The Doctor is coming on Wednesday. Ooh, more Doctor Who. That is good. Oh, no boom today, always boom tomorrow is a line from Babylon 5. That is true. I forgot that reference. Thank you. Looking. Whovians happy on Wednesday. Yes. Larry's commenting on a new experiment that has been talked about a lot in the news where Legos were used as insulators for an ultra cold experiment. And I just love that idea. Arian Ravage is saying, I can deal with time zones, but daylight savings has to go. Yes. Yes, it does. There's this fabulous back-to-back set of comments. Sad face, I don't have BBC America, followed by, I have whiskey. Two different people, but I just love the combination. Beer and board games sounds like an excellent idea. Yes. Yes. So Terax also followed. Thank you. Oh, Paranor mentions Canadian Thanksgiving, and actually the Division of Planetary Sciences meeting does ruin Columbus Day and Canadian Thanksgiving. I had forgotten that. So Undercover Bass, not studying. Thank you for the bits. Studying law instead of science is excellent because scientists really, really need lawyers. Whoa, hi, you are excited about this. I see you. Okay, there, a little bit for both of you. Oh, my dog loves it when you give bits because he gets Cheerios. Let's look and see. Yeah, this meeting is in Hawaii for the AAS. Um, so yeah, it's one of those things where yay Hawaii, boo work trip that is stupidly expensive. So I don't currently have grant funding to cover this trip. So my husband and I are also turning it into a vacation so that I can kind of tolerate the amount of money. I need to be there because a book that I wrote a chapter in, a research book that I wrote a chapter in, is getting released, and they're doing a workshop on the content in the book, and then they're having all of us present. But the meeting itself, I want to say, is like $650 to register for the meeting. So that's just to get through the door. Then the airfare is over $700. And then on top of that, you still have to pay for hotel. And there's no such thing as a cheap hotel in Hawaii. And all the hotels have resort fees on top of everything else. So this is a stupidly expensive science meeting. And to pay for it out of pocket is like a month of my salary in order to do my job. And that's what it means to be an astronomer. And thank you for the further bits. Bill Nash continues, the murder clone thing is serious business. What would society be like if you could just buy a clone of someone so you could vent your frustration on them without repercussions? Or if you could just steal a copy of someone for interrogation? I should write a book. Yes. And you should also read Mur Lafferty's book, 6 Wakes. It gets into a lot of this cool moral ideas about cloning. I like Limp-Brimble. My cat has a theory about string. She thinks it's super. I agree with your cat. String itself is super, and as a knitter who pretends to crochet occasionally, I find so many uses for string, especially really thick string you can call yarn. But string theory is weird, and supersymmetry seems unnecessary. Thank you for the follow, Carl Allen. And I think I've finally almost caught up to the beginning or the end. Thank you, Carl Allen, for saying my voice is hypnotic. I actually narrate stories in the evening over on my personal Twitch channel. This is my work channel that CosmoQuest does science outreach, and we cover rocket launches and landings and a whole variety of other things. So if you want to hear me read, follow Star Strider with a Y. And a lot of school nights, I narrate books because who doesn't need a bedtime story? Looking to see what else is in here. Hello from the UK. I enjoy your country. I've been there several times. Thank you for the additional bits. Okay. Doggos want more treats. He's being more patient this time. Oh, there we go. There we go. Hi. Malachi. Come here. There we go. There. Nothing like a floof. Nothing like a floof. All right. Let's see what else we have in here. Bill Nash is like, so point a scope at Betelgeuse for New Year's Eve? Yes. If it's clear New Year's Eve, he'd stream that. You know, if you are streaming New Year's Eve with a telescope, I would happily jump in on that. So undercover Bass is asking which board games. So if I'm playing in person, it will just be whatever the group wants to play. I have to admit to being the kind of nerd that I have an entire bookcase of board games. Now, my collection is nothing compared to our own Susie Murph's collection because she has multiple bookcases of games. If I'm playing online, we actually have a lot of us that like to play Uno and Ticket to Ride over on the CosmoQuest Discord and occasionally other games. So yeah, we'll be playing what we can all play together with the special understanding that I use a Mac. I really need to set up a PC. Thank you, Broken Symmetry, for all of the bits of puppy love. So much chat today. So much chat. Thank you, Wally KC. Let's make this happen. You guys are awesome. You guys are awesome. I shall give more bits to the dogs. And Bill Nash is like, conferences are expensive. Yes, yes, they are. Hi. You're very cute. Here, come over on camera. Come on over on camera. There we go. You're good too. You're both good. Hi. Can you see his nose even? No. He's like, I don't want to be on camera. Okay, scrolling. Use the clone for driving in HOV lines. Yeah, that would work. Veronica says, work conferences should totally be held in more boring and cheaper places. So I don't agree with you on the boring because it's really hard to find places to eat in really boring locations. I was at one conference that was held in a random hotel in Greensville, and there was no good food within walking distance. But cheap places, there are plenty of cheap places. Hawaii is not one of them. Oh, yeah. Bill Nash is like, oh my God, the tagline for 6 Wakes. Maria Arena awakes in a cloning vat, streaked with drying blood. She has no memory of how she died. Yes, I will admit to being the science advisor on that, so I am biased. But the book has won enough awards that I have no shame in completely bragging about the book. Wayne is like, we can get you to Hawaii one bit at a time. Thank you. Broken Symmetry asks, can you spin a good yarn? Depending on the definition, the answer is yes or maybe. Looking. Thank you for the bits, Wayne Johnson. Thank you for the bits of melty snowmen that are so sad, keeper of maps. Actually, those aren't melting. Those are becoming unicorns. Those I like. The melting ones make me sad. The becoming unicorns ones make me happy. Yeah, Bill Nash points out that altered carbon also points out the issues of having your soul in 2 bodies at once. Wiggle bets. Yes, I have 2 of them. So many books I need to read. Okay, so apparently, like, no one will play Ticket to Ride with me anymore because I like to win. Yeah. So Bill Nash, the way to make the weather better is clearly to take your telescope out of your truck, carry it inside, put it away, and then it'll be clear. This is how that works. Thank you for the bits. Oh man, I'm just going to sip to the bottom to see who it is. Thank you, Paranor, for the bits. You're discussing Pavlovian reactions to all sorts of different things. Scroll up. Susie's like, hey folks, get us to 10,000 and I'll make Pamela play me in Ticket to Ride on stream. I'm fine with that. And if we make it to 20,000, I have agreed. Eddie's just put his paw on my leg, reminding me that he's deserved Cheerios. I will eat the ghost pepper chip. Hi, here. Apparently, we're going to have lots of Cheerio eating ASMR today. Yes, Binary puts it in there. She'll eat the chip on stream. And yes, Susie will be doing Monday's Daily Spaces starting next Monday. Bill Nash is like, that weather comment is too savage of a truth for a Monday morning. That is why Irish coffee was invented. Yes. And I finally caught up on the chat. So I'm going to take a break from stream to go make some lunch and go somewhere warmer in our house because I forgot to put a sweater on before coming down here. Today I will be streaming, working on software and servers as we move into the new year and making CosmoQuest more and more open source. That's all I've got. Thank you all for being here. Thank you for the follow, Raj Nord or Rai Nord. I can't say your name. I will be back later today, probably in like half an hour to an hour. And I will be working on software development for CosmoQuest, making it so that all of you who worked on Bennu can, well, see your name, not necessarily in lights, but in publication. Thank you. What chat scrolled. Thank you for following Raylo. Yes, Limp Rimble, open source. So that's all I've got today. And as always, this has been a production of the Planetary Science Institute. Our producer is Susie Murph. I will be back tomorrow, bringing you the Daily Space once again at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. But before that happens, I'm going to be back here working on developing our site. Today's top to-do items are working on our servers with Amazon, basically figuring out our infrastructure for the next year. You're going to have to deal with me setting up Lucidchart because I need to set it up to document how we're setting up everything. And I think I'm also going to be working on porting our WordPress, which is currently being, hi dog moved desk, which is currently being very sad. So yeah, if you want to learn more about Amazon Web Services, if you want to play deep in the bowels of WordPress, all these things are yours. So I will catch you later, but first I'm going to catch some lunch. Before I go, I'm going to attempt to roll the credits, which is going to require me to loom in strange directions, trying to figure out what window the credits can be rolled from. Log in with Twitch. I will have things better set up tomorrow. Mondays are always rough, and I couldn't find one of my cameras this morning, so you're not viewing me on my normal camera. I want that button. I want that button. All right, so we are maybe good to go. All right. Thank you all wherever you are for being here. Remember, if you have clear skies, go outside. Look at Betelgeuse. See how weird the constellation of Orion looks? Let's all hope together for a supernova explosion, knowing full well the universe doesn't care what we hope for. And wherever you are in the world, have a fabulous morning, evening, or afternoon. And, well, I'll see you on the other side of lunch. Bye-bye, everyone.